minimum flow rate and minimum volume. What is the difference and how to calculate? When I put video buffer yes or no and explaining that buffer is not needed in most of the installations, there were different feedback and really appreciate that. Some colleagues, people from the industry, and explained that I'm always focusing on pump pressure drop and flow rate. And one of my colleagues said that in some countries it's mandatory to have individual regulation. And with individual regulation, you are reducing volume of the installation, and you will have a lot of cycling. Lots of cycling means lower COP, more consumption, and so on. Basically, this could be also avoided with some volumizer, bypass valves, but this is not the main point of this episode. The main point is how to calculate enough flow rate so you can have stable operation of your heat pump. I put here some different things. I will put also some tables and some references so you can see. But basically, if we have heat pump capacity, for example 7 kilowatt unit at some design outdoor temperature, this 7 kilowatt unit needs some volume to operate correctly without a lot of cycling. And what is also important, for me more important, what is the minimum output? Usually it's 25, 30, 35% of the nominal output, depending on outdoor temperature, depending on manufacturer, depending on algorithm. For some units we have data, for some we don't have, but let's say that it's around 30 to 40%. For example, 7 kilowatt unit has minimum output 3.14 kilowatt. 7 kilowatt, we have open loop system, let's say 100 liter, and our design outdoor temperature is -3 degrees. So with this 7 kilowatt unit, our heat loss is, let's say, 6.8 kilowatts, and we decided that we need 7 kilowatt unit. For our heat loss of 6.8 kilowatt, when we divide our heat loss with temperature difference between outdoor and indoor, so 21, for example, indoor, if we want 21, outdoor is -3, so this is 24. When we divide 6.8 with 24, it's 0.283 kilowatt per 1 Celsius. So it means 283 watts per each Celsius difference. And now, if we have outdoor design temperature, which is clear, -3, and now if we want to see what will be with our minimum output, so when the unit will stop at what outdoor temperature, we need to put this here, the same formula, but not with 6.8, and now we need to put 3.14. And if we divide 3.14 with 0.283, we have 11 degrees Celsius. What means 11 degrees Celsius? 11 degrees mean temperature difference between outdoor and indoor. So in that case we don't have 24 degrees difference, we have 11 degrees difference. And with 11 degree, from -3 plus 11, outdoor is 8 degrees. So at outdoor temperature of 8 degrees, our heat pump will not modulate. So above 8 degrees, it will go on and off. This is quite good, but there is also differences. Someone wants to have full modulation or whole range. It's much higher to have that with low outdoor temperature. And you can help yourself with system volume. So we have minimum, maximum output, and we have system volume. Here we have 100 liters. For example, 7 kilowatt unit, let's say 9 liters per minute minimum flow rate. It means 540 liters per hour. So we have flow rate 540 liters per hour, and we want to ensure that our compressor will have 5 starts and stop per hour. So 5 times will start in each hour. We need to divide 540 with 5, so liters per hour with hours, and we have volume of 108 liters. We have 100 liters, so it's fine. Our compressor could start 5 times per hour and we have enough volume. What if we want to reduce our start-stop per hour and we want, for example, 2 times? If we want 2 times, we need to divide the same flow rate, so minimum flow rate on minimum output. 540 divided by 2, 270 liters. So in that case, our 100 liter system volume is not enough, and we need to add some volumizer or buffer if you want. So we need to add additionally 170 liter on this installation. If we want lower, we need to calculate. So this is basic formula. Calculation is much more complicated, and usually you cannot calculate this. So it depends on algorithm, it depends how compressor and pump are modulating, what is the minimum output. So this is only the case, some case with some heat loss, some design outdoor temperature. And we can see here that we need to ensure modulation and we need to ensure volume. If we have open system, it's not a problem. But for example, if this 100 liter will not be open loop, in this case, you will have even lower volume of the installation and your compressor will go much more on and off. So we will have, if some zone is closed, you will have less volume. So volume is important at the same point like flow rate is important. So flow rate is important so we can pass our energy, our heat to our emitters, to our house at some point. Volume is important to have stable operation, to have good modulation, and to have good defrost. Defrost is not the topic of this episode, but with huge volume, your defrost cycle, when you have ice on outdoor units and you need to ensure that this ice will melt down, you need enough volume. Enough volume means enough energy to do the cycle. With low volume, your defrost cycle will take much more time. In that time you will not have heating or hot water, and your operation will not be stable. Some new heat pumps, Panasonic new series has defrost from the hot water side, so really good point if you don't have enough volume. But still, you want enough volume. Volume is like fuel for car, so you need enough to have your system work smooth and work good. Thank you for watching. See you in next episode.